Hello and welcome to That Fabric Guy, and today I'm going to show you how you can use Python notebooks inside Microsoft Fabric together with DuckDB in order to speed up your query process on Delta tables and maybe save you some money because you won't need to start a Spark cluster anytime you want to do some simple querying. I've never worked with DuckDB before myself. On my other screen here to my right I have opened some documentation and some examples, so let's find out how easy it is. It is supposed to be very easy, so I think we will be able to figure it out in a couple of minutes today. So let's dive into my laptop. All right, we are looking at my laptop screen and we are looking at a notebook, to be fair, a Python notebook here in Microsoft Fabric. So what I've done is I've went into my That Fabric Guy workspace. I've created a new notebook and I called that notebook DuckDB here. The name doesn't matter for now, it's just so that I can find all of these examples quite easily. And if we go to the language toggle here on top, that is actually where the magic happens. Right now it is set to PySpark Python. We will need to set this to Python because the runtime will not be the Spark runtime. We will actually run this inside a Python runtime. Now, mind you, there's only two versions of Python that we can use, 3.10 and 3.11. The more recent ones are not included in Fabric at this time. I think 3.11 should be fine. Now, what I've also done is I've attached my Gold Lakehouse to this notebook in order to start working. Now, before we can start working with DuckDB querying on our Delta tables, we have to create the DuckDB import first. So let's create a cell here that is doing my imports, and we say import DuckDB DB. And when running this import, you can hit Control Enter on a Windows laptop or Command Enter on a Mac. You find that the session is started in a couple of seconds, and actually the computer is really fast on a Python notebook because there's no Spark cluster that needs to be started up. And also we're using just one machine for Python instead of at least two machines with an orchestrator and a worker in order to run Spark. So this should be faster and cheaper. So now we imported DuckDB and now we can start creating the connections, the source path and so on. So let's look at our documentation over on the right here, and let's start creating a connection. We'll create an object here, connection, or called con, and we open duckdb.connect. That's fine. Let's define a source path for our Delta tables. That should be in Lakehouse defaults. And Lakehouse default is the Lakehouse that we have added here, and where you see the spin icon is your default lakehouse. So we can add more than one lakehouse. This one will be the default. And when reading from one lake/lakehouse/default, we will actually be reading from that lakehouse. Now we can read from tables, because if we open up Gold, we will find that there's two folders in that data lake, basically. One is called tables, one is called files. So we want to read from tables in this case. And here in tables, we have multiple tables. All right. So this should be all right, I think. Let's start looking at dim dates, gold_dim dates. All right. Now we want to register our Delta tables. So we apply the execute to our con object, and let's make this an f string, a dynamically create string, and we say create table, source table, let's call it gold dim dates as select star from delta scan, which is a command in DuckDB, and then we put in the source path here. And now what this is doing is that these accolades here are injecting the value of the source path variable into this string, and we can do so by putting an f in front of a string definition. All right. Now let's run this cell. We get an error here. There is an error near the slashes that we have put in. And I'm actually not sure why. Yes, I had to put in, okay, we need to change this around a little bit to double quotation marks, and then this delta scan needs to be applied on a string. So we have to put in these quotes there. And now running this should actually indeed create a connection to a table called gold.dimdates. And now what we can do here, and this is actually where the magic happens, is we start creating objects by saying, for example, df select equals con.execute. And now we can start running queries here. And what I always do, multi-select, we create these 3 quotation marks, like so. And then we can put an F in here in order to make it dynamic. Maybe we don't need to, but maybe we do. I don't know yet. Select star from, call it gold dim dates. And now when we run this actually works. So, oops, my apologies. So now we can start doing display, df select. And this is actually taking a while. We see that there are some CPU cores and RAM being used by our Python session. But we should be all right here. Why is the display here not working? Ah, I see. So I forgot to actually fetch the output of this query, the result, into a data frame. So we do fetch df. And now we should be finding the data of this table indeed. Okay, so this is something, because I wasn't working with DuckDB before, and I have not prepared this except for reading a few documentation posts. So this is truly new for me as well, but it's also showcasing how easy and how convenient it is to set this up. If you know a little bit about Python, it will be very easy, very convenient to set up a DuckDB connection and to start writing SQL on your Delta tables, and that's actually really cool. My recommendation here would probably be to not start reading billions of rows through DuckDB. If you really need to process those big numbers, you will benefit greatly from Spark's distributed compute power, where you can create a Spark cluster with multiple nodes all doing their own processing basically. So as we can see here, that would not be feasible with DuckDB. However, if you're working with smaller tables like a date dimension or taxi types or any other smaller datasets that you might have, then Python notebooks using DuckDB and SQL will be helping you in order to save a bit of money by not running the more expensive Spark clusters in Microsoft Fabric. Now, if you like this video, please subscribe to my channel, because every week I will be posting videos like this explaining bits and pieces from the Microsoft Fabric ecosystem. And I hope you find value in this. So if you did, please help me and provide some value back to me by subscribing. And I'll see you next week.